Hi, this is Rajkumar from BIM Modeler. Today we're going to discuss the conceptual modeling of United Tower. We're going to use Dynamo and Revit to create the same. You will be able to download the working files and the script files dyn file from the below link. You can see that I have already footprints of the building. I have drawn in model line. Let's start Dynamo. Start with a new file. We need to select the model element from Revit. You can search model element. I need multiple elements to be selected. Use select model elements option instead of using single element. I can use the select button. I can use the select button and I will be able to select the building footprint. The next thing we need is the element need to be converted as geometry. So I have to search for Element.Geometry node. Now you can see the footprint on the back side. Workspace, zoom to fit element. Control B to swap the space. I can check the list. It contains the list inside the other list. We have to flatten it out. I need a node called flatten. It requires number of value. By default its default value is -1. It's enough to have. Now we get the 8 number of lines, which is need to be a joined curve so that we can achieve the close to loop of Polycurve. Let us search for Polycurve, which will combine the curves into a Polycurve. Polycurve by joined curves. We have curves, the joint direction tolerance. You can see that number of polycurve is 8. The single element polycurve which is created. We can hide the remaining element if it is not required. We need a number of stories, or we need a building height to be defined before creating a 3D element. We need a curve profiles. So we have to transform the element into the different heights or different intervals. It's a geometry transformation. So we need a transform node, geometry transform node. It requires geometry, which we already have, a coordinate system to be defined. Coordinate system. Coordinate system by origin. With 3 values, and it requires to be a Z value so that it will go horizontally, not in horizontal, it will be in vertical. We have to define the series of height, so we require a series of numbers. There is nothing but from the 0 to height and the space. We need to control this height and space. We can use the number slider. The height may be the space, one-to-one space may be 12. The maximum height, building height, you can define that as building height as 100 as of now, or maybe 200. It will be an Z value, and now we will be able to transform our geometry into the Z axis as like this one. For a united tower building, it will be a twisted one, so we may need a twisted geometry to be defined. So it requires a geometry twisting. I mean it requires a geometry rotation. So it's a geometry again transformation in rotation in a different angle. Rotation. Rotate geometry, line axis. It should give a geometry output. The geometry will be the output of transformation. origin will be our 0 0 origin. Axis will be about Z axis. We need the different degrees from 1 to 360 degrees. So we can define our own codes 360 degree. We can control the degree value if it requires using a number slider. We can hide the remaining geometry so that we can see the output. Now using these closed profiles, we'll be able to create a loft, Solid.Loft. It requires a cross sections curves and it creates a solid. Solid. The other one it is for Surface.Loft. The other one creates surface which it doesn't require. Now we will be able to control the geometry and height of the building. Using our slide bar, we will be able to control it. Even we will be able to control the spacing between the floors. And we also able to control the degree of rotation. The United Tower also have a base building which requires a select model from the footprint from the model. Select model element. You may see a temporary Dynamo elements. Click the select button. Select the isolated 4 footprint elements and using the same method and till the joining the curve, use the shift key and select the elements that the nodes which you wanted to copy. Hold the control key and drag it. turn on the preview so that we'll be able to see the building footprint on the other side of the twisted building. We may have to control the or align the twisted building nodes. Press Ctrl L to realign the nodes. Press Ctrl G to group it and say twisted building, and you can change the color of the node. The building which requires a simple extrusion, so we will be needing a close to profile, which we have, and we have to create a Surface.ByPatch node. It will create a closed patch surface. Then we will be able to create a thickness using thickening the surface on both sides or single side you can use. It requires a surface and a thickness, and you can use the slider to give the thickness, and it will increase the thickness and you can control the values by minus or plus value. Due to that, it will increase in the opposite directions. You can control that. Control B. Now you'll be able to see this extrusion, the thickening happening on both the side. We need to control that by using Boolean variable. And we have to multiply this value into -1 so that we will be able to get the negative value, and it will be in the opposite direction. Now we'll be able to control the height of the building. Now we have two different solids. We have to create a single solid by using a Solid.Union method. Create a list of solids. There are two number of solids. The one is twisted building, the other one is supporting building. ByUnion. It requires list of solids, array of solids. Now it will be a single solid model. You'll be able to see in Revit there are only a temporary Dynamo geometries. We may need an additional geometry for our reference or for our future modeling. We can import our Dynamo geometry directly to the Revit by using ImportGeometry. any one of these nodes. Since we have only single model, we'll be able to use the import instance geometry. Before that, we'll be able to align it and Control L, and for grouping Control G. Support building. Now you will be able to see the instance of the model what we have created. That's it for today. We'll be seeing again with another tutorial. There are more tutorials to come. Subscribe to BIM Modeler. Support us. Also, you can get the files, DYN file on the below link. You can download. Thank you so much. Bye.